Alright, we've got triangle DUG, which is not drawn, so I'm definitely going to draw it. It is an isosceles triangle, and it is also a right triangle with the right angle at G. So it's isosceles and it's a right triangle. Let me get my diagram of this. Here's my right angle. Here's my two congruent sides. And it says the right angle is at G. Oh, we got that. And it's DUG. The D and the U placement doesn't matter. If DU is 10 times the square root of 2, what is the length of GU? And for those of you watching this video, here's some shortcuts that I did not teach this year. But there are these things called special right triangles, where there is a relationship between the sides in what I know is a 45, 45, 90 triangle. These two angles have to add up to 90 degrees because we've got the other 90 there to complete the 180. And in this case, I already know the answer is 10, but I will show you the long way of doing this, where I don't always teach this topic because you don't need to know it. There are longer ways to do it. We know these two sides are congruent to each other. And this is a Pythagorean theorem question. So this is one way that I know that I can use the Pythagorean theorem. Nice little clue from the question. It is a right triangle. This question is all about the lengths of sides, three sides, Pythagorean theorem. So this is x squared plus x squared. Important that you understand that you can represent these both with the same variable because they are congruent, equals 10 root 2 squared, and x squared plus x squared gives you 2x squared. This I'm going to do without a calculator, but you can just plug it into the calculator. This is 10 root 2 times 10 root 2, and 10 times 10 is 100. The square root of 2 times the square root of 2 is the square root of 4, which is 2. So this is 200. So you get 2x squared equals 200, and we're solving this equation. Divide by 2. You get x squared equals 100. Take the square root of both sides, and you get that x equals 10. As I said, I already knew was the shortcut. So the shortcuts in a 45, 45, 90 triangle, a lot of the time the way we represent it is we just write x, x, x root 2. It's just the result of the Pythagorean theorem being used on this type of triangle. Basically just means these two sides are congruent, and this side is whatever this is times the square root of 2. And the other one that is, it's on the SATs a lot. If it's on the Regents a lot, I'll start teaching it a little bit more. But it's the 30, 60, 90 triangle. Across from the 30-degree angle, we put an x. Across from the 90-degree angle, it is always twice as big. That's 2x. And across from the 60-degree angle is in between those two, x root 3. So if I told you that this was 5, that would mean that this is 10, and that this one is 5 root 3. You can usually do it without the shortcut using the Pythagorean theorem. Shortcut is just a shortcut.